Okay, a good morning to you all. Another session, logic design and switching circuits. We only have, I think, one important topic chapter to do, one last important chapter to do, sequential circuits. Sequential circuits. But before we go there, I just need to put out some more information on the last examples of combinational circuits that I introduced. I introduced a decoder, encoder, multiplexer, and a demultiplexer. I just introduced you to how it functions. I explained how the multiplexer, the encoders function. And now I'm going to give the circuits because those devices, nope, those circuits are made of logic gates. I see chips, they're made of logic gates, right? What do I mean? For example, we have a decoder. I said a decoder is a combinational circuit that converts n input and gives you 2 to the power n output. Symbol, this is an IC, input 0, input 1. Those are 2 inputs. There is the enable input. What this gives you? 4 outputs. Y0, Y1, Y2, Y3. So this is it. This is called the 2 to 4 decoder. Now, inside here, inside this thing, that is where your logic gates are. But what does the circuit look like? What does the circuit look like? How we come up with the circuit of, let's say you have a problem. How do you come up with a circuit? First thing, truth table. We now know that. Second thing, logic expressions. Third thing, your circuit. Here is my truth table for this combinational circuit, the decoder. These are my inputs. Then I have my outputs, Y0. Let me say, okay, Y0. Let's start with Y3. MSB, Y2, Y1. Then I have Y0. These are my outputs. Output here. Right. When the enable is 0, when enable is 0, when enable is 0, what that means is you don't have input. So consequently, you have 0 in the output. Morima Lovejoy, be very careful entering the session without meeting yourself. When you have enable 1, it now means your decoder is functioning. You can now have inputs 0, 1, 0, 1, 0, 0, 1, 1. This is 1, 1, 1. When your enabling input is 1, it means your decoder now is functioning. When it is 0, it is not functioning at all. You have 0 output. Now, how the decoder works? For a specific input, in this example, 0, 0, you have 1 output. And the rest are zeros. Next one, 2, 1, output, zeros. 3, 1 output, zeros. 4, 1 output, zeros. This is how the decoder works. So if you have an input, of 0, 0, using these 2 inputs. So if I have a 0, 0 here, What it means, only Y0 will be selected. You have Y0 in the output. If I change, I have 1 0 here. What it means, only Y2 will be selected. Only Y2 will be selected. From the truth table, I can then go on and give my logic circuit. This is Y3, Y2. I can then give my logic circuit. My logic circuit will look like this. I can move this. It has the enable input. It has the I0 input. And I have the I0. I have the I1 input. And I have the I1 not. How many outputs do I have? I have 4 outputs. Y0, Y1, Y2, Y3. When output is Y0, here, what is the expression for Y0? What is the expression for Y0? What is Y0? Logic expression for the output Y0. Sum of products.
Enable B.
Exactly. Enable I0 bar, I1 bar. This is Y0. So then can go and draw Y0 here on my circuit. I bar, bar. This is an AND output Y0. Y1, same difference. Y1, I only have output Y1 in this case. So this is enable I0 bar and I1 like this. So I have these 3 again and Y1. For those who are a bit slow, not as an insult, I1, Y1, this is enable I0 bar I1. Y2, enable I0 I1 bar. Y3, enable I0 I1. Now to the logic diagram, Y2, I have enable I0 I1 bar Y2. And the last one, enable I0 I1 Y3. So this is a decoder. This is what the decoder looks like inside the chip. When you have a chip, what the chip will look like, it will just look like this. Inputs, Y0, Y1, Y2, Y3, enable, I1, I0. But inside here, you have a bunch of gates arranged like this. So that is what the decoder looks like. So now, another demonstration. What does the decoder do? The decoder applications selects different devices. 1, enabling different rows of memories. Applications wire. Selecting different devices. So how does the decoder select different devices? For example, you have 4 devices. 1, 2, 3, 4. Instead of using 4 inputs, input 1, input 2, input 3, input 4, to select these 4 devices, I can use only 2 inputs. How do I use those 2 inputs? Application of the decoder. It means if I have 0, 0, for example, here, only one input comes up. If I have 0, 1, the other input comes up, the other device comes up. If I have 1, 0, another device is selected. If I have 1, 1, another device is selected. That is how the decoder works. Sibia, what is your problem? Sibia,
Uh,
pane chiri
say,
kuvhara.
yeah, when is soon to see, I'm going to go to the Bananan.
You can rewatch the video. Can also warasika papi, that's an issue. It means you are not even following. Can also warasika papi, that's an issue which you have to deal with on your own. This is how the decoder works. Voila. You can go back, revise. Another combinational circuit. We have the encoder. We dealt with the encoder, and we said the encoder, if you have 2 to the power n inputs, it can give you n outputs. Logic block diagram. So I have 8. An example. The example I used, it had 1. So I can have something like this. 1, 2. Nope. Let me do this. Let's use a 4, 2. 1, 2, 3, 4, giving you 2 outputs. So this is a 4 to 2 encoder. Enable. I have I0, I1, I2, I3, Y0, Y1. I can go on and construct a truth table for this. Inputs, I0, I1, I2, I3. Enable as well. Outputs, Y0, Y1. Application, I can use this encoder maybe to encode numbers from 0, 1, 2 to 3. I want to encode those numbers so that if I have a 0 in the input, my output will be 0, 0. That is encoding. If I have a 1 in my input, it encodes 0, 1. 2, 1, 0, 3, 1, 1. That is encoding. Now with this, I can put up a much simpler truth table with only the enable and the inputs. Right, my inputs, I have 0 here, dash. I have 1, 2, no, 0, 1, 2, 3. All right, 0, 1, 2, 3, 1, 1, 1. Provided it's just an enable. Or let's say it's already enabled. Let's remove this. We're dealing with an encoder which is enabled already. Let's remove this because there's a lot of confusion. All right, there I have my inputs, binary numbers. decimal numbers. Decimal number 0, decimal number 1, decimal number 2, decimal number 3. I want to show application of an encoder. I have 4 inputs. Now what the encoder will do, it will code. For 0, the output here it will be 0, 0. Here 0, 1. Here 1, 0. Here 1, 1. This is what it does. For 2 to the power of n inputs, you can encode 2 to the power n inputs using only n output bits. Instead of using these 2 to the power of n for encoding, I can only use n. That is the application of an encoder. Perfect use is a binary number or a decimal number corresponding to the inverse. In this case, we have a binary number corresponding to the input. This is a decimal number. We have a binary number corresponding to the input, which is the decimal number. So in terms of a calculator, 10 minutes. In terms, you have a calculator. You have a calculator, number 0, 1, 2, 3, until 9. Instead of having every binary number for all these, I can represent these values using only 4 bits. So if I click 0 on my calculator, the calculator will transmit this information using 4 bits. If I click 1, the calculator will transmit this. 2, it is using only 4 bits. But how many input bits do we have here? Inputs, we have, this is an input, this is an input, a lot. Maybe until I reach 16 here. But how do I represent all these 16 inputs? I can only represent them using 4 bits. That is how an encoder works. Taking a lot of inputs and using a much smaller, in this case, n output bits to represent 2 to the power n inputs. Circuit. Circuit. We can draw a circuit for this one. How do we draw it? We can draw a circuit for this one. 0, 0. All right. My output, I have Y0 and Y1. My inputs, I have those. So I have my inputs 0, 1, 2, 3. My output for 0, let's say Y1. What is Y1? Here, this, and this. Y1 is equal to 1 plus 3. Sum of the products. We are summing a solution where it's 1 here and this one. 1 plus 3. So if I take this input and if I take this input plus, this is an OR gate. If I do this, I will get Y1. For 2, not for 2, for Y0. Y0 is equals to 2 plus 3. So if I take 2, if I take 3 OR gate, I will get Y0. With this, I have my encoder. With this, I have my encoder. So my encoder is looking something like this. I have my encoder Y. What was this? This was Y1, Y0. With my inputs and my outputs like this. So I have 4 inputs. And this can only be represented with these 2 inputs, 2 outputs. So inside this 1, 2, 3, 4, 1, 2, I have this here. And that is how an encoder is built. Another example, we used, no, 5 minutes. Yes, we can add another example. Another example, we used mux, a multiplexer. Symbol, a multiplexer, it looks something like this. 1, 2, 3, 4. This is a 4 to 1 mux. What the mux does, it accepts multiple inputs. It accepts multiple inputs. In this case, we have data selectors here. We have D0, D1, D2, D3, S0, S1. It accepts all these multiple inputs, and the output is only 1. This is your output. How can we construct the truth table for that? The truth table for this depends on these selectors here. So we have selectors, 2 selectors. This becomes your input, and you have your output Y. Since I have 4 here, I have 4 possible outputs, 0, 0, 1, 1. When my selector is 0, 0, my output can be D0. When my selectors are 0, 1, D1, D2, D3. Now, the output Y is the sum of all the inputs, is the sum of all the inputs here. But how do I get the inputs? How do I get D0? I have D0, S0, S1. This is S bar, S bar. I only get D0 when the selectors are 0, 0. Sum of plus, I get D1 when the outputs are, this is 0, 1. So this is S0 bar S1 plus D2 S0 S1 bar plus D D3 S0 S1 no bars. So this is my output. So in a case where this selector 0, 0 wasn't there, it means you don't have this. Your output will be like this. In the case another one was not there, you have something like this. So this is the logic expression for a multiplexer. You have a number of inputs, 4 in this case. These are the inputs. And with the function of these selectors, I can then get an output, which is a sum. It accepts multiple inputs and multiplexes them, bringing out one output. So my output, as you can see, this is one output. How do I draw the logic diagram for that? How many minutes? 2 minutes. Logic diagram. I have my inputs D0, D1, D2, D3. I have my selectors D1, 0, D1, D2, D3. I have my selectors S0, S1. So this is S0. I have another selector S1, S1 not. Right, back to my equations. Y is equal to D0. How do I do this? Y is equals to D0 S0 S1, D1 S0 S1, D2 S0 S1, D3 S0 S1. So bar bar, 1 bar, bar bar, 1 bar, 1 bar, plus, plus, plus. This is my Y. So I have a sum of D0. This one S0 bar, this one S1 bar, this one end. This is an end. Here we have an end with an output. Then we have this one. I continue. There is another end. I have for this one, I continue another end. For this one, I continue another end. And all these ends, they are being summed. You have an OR gate like this. Your output is Y. Less than 1 minute. Let's continue. I'll continue with the next session. We join soon after. Soon after.